of inductive reasoning. So after looking at the PowerPoints and seeing some of that terminology, the number sequences, whether you choose if it's a arithmetic sequence, which is adding or subtracting, or a geometric sequence, which is usually by multiplication, or a common ratio. The first thing we're going to ask to do is, for each sequence, determine if it is an arithmetic sequence or a geometric sequence, or neither. And if so, figure out the next term. So on the first one, 6 to 16 to 26 to 36 to 46, well, it looks like adding 10 each time. So we're just going to make a note that says we add 10, and it's an arithmetic sequence, and so the next term would be what, 56? Alright, looking at number 3, 5, 15, 45, 135, 405. That gets pretty big quickly. So probably multiplying. So 5 times 3 is 15. 15 times 3 is 45. So we're multiplying by 3. And since it's multiplying, it's a common ratio, which is geometric. And then that means we need to take 405 and multiply it by 3, and that would give us 1,215. Alright, one more, 0, 1, 1, 2, 3. You can't add, 0 plus 1 is 1, but 1 plus 1 is not 1, so you can't add to get to the next term, or subtract, and we can't multiply to get to the next term. So if you can't add or you can't multiply to get to the next term, this one is going to be a neither. This is a sample of neither. Okay. The next thing we're going to look at is the successive differences, and you've probably seen a little bit of this on the PowerPoint, but I'm going to break it down for you so that's a little easier to understand. They want us to determine the next term in this sequence right here. Okay, but to do that, we got to figure out what's going on. So first of all, when I go 1 plus 3 is 4, 4 plus 7 is 11, 11 plus 11 is 22, 22 plus 15, 37 plus 19 is 56. So we figure out that much, but then we're going to keep going. So now you dig back another layer. So 3 plus 4 is 7. 7 plus 4 plus 4 plus 4. Well, now we're at the point where we can see all of the bottom level is something that's predictable, and we see that there's a pattern. Everything has that successive difference of 4. So now we can predict that this would be 4. 19 plus 4 is equal to 23. So now that we know that value is 23, then we can do this to figure out to get 79. 56 plus 23 is 79. So kind of work your way backwards. So basically you work your way down the tree till you get to that common value. Then we know that, and we work our way back up. Alright. Let's just practice another one of those. Let me go back with first figuring out what's going on. How do you get from this term to this term? That's 6 plus 14 is 20. 20 plus 30 is 50. 50 plus 52, or if you want to look at it like 102 minus 52 is 50. However you want to work that, depends on your preference there. So 102 plus 80 is equal to 182. Then 182 plus 114 is equal to 296. So we got to figure out 296 plus what is going to give us the next value. Okay, so the only way to do that is to keep working backwards. So we're going to work our way down. 14 plus 16 is 30. 30 plus 22 is 52. 52 plus 28 is 80. 80 plus 34 is 114. Okay. Still nothing common going on, so we got to keep going. Keep peeling back the layers. So 16 plus 6 is 22. 22 plus 6 is 28. 28 plus 6 is 34. So now that we have all common 6's on the bottom, now it's safe to say 34 plus 6 is 40. And then take that and go back up. So 114 plus 40 is 154. And now we can work that up. So 296 plus 154 is 450 to get to the next term. Okay? The next thing we're going to do is just like the last lesson. You look at the pattern and then you figure out the next term in it. Well, you can see in this one, let me go back to blue, that this did not change. So I'm going to leave it alone. Times, we went from 2 to 3, so my next one will be 4. Over here, assess the right-hand side, so 1, 2, 3, leave this alone. 9, 9, and then we went 8, 7, so we're going to have a 6 here. Okay. Alright, next one, 29, just following a pattern. 2 squared, 3 squared, 4 squared. This is obviously going to be 5 squared. 1 squared, 2 squared, 3 squared, 4 squared. Then we have 2, 3, 4, 5. 1, 2, 3, 4. Okay? Alright, the next one you're given a formula, and it says use this formula to find each sum. And I'm going to give you a hint. The hint is to find n, to find n that you need for the formula, add 1 to the last term and divide by 2. That'll tell you how many number of terms in the sequence. Okay, so for number 33, let me put this in purple so you can see. For number 33, n is going to be S. Hold up, wait up. I got ahead of myself. We need this. I'm looking at the wrong problem. Scratch that for now. We'll need that for this n squared one. Alright, sorry about that. We're just going to plug in the formula here. So we have S is equal to n, and n is your last term right here. So this is n. 300, we're filling in this n, comma, n plus 1, divide by 2. Okay, so then when we plug that in, you're just going to have 300 times 301 divided by 2. In this case, that's 45,150. You can go ahead and calculate that. So we're just working on plugging into the formula. This one's pretty basic. Okay, so we have our next one. S is equal to n. This time n is 675. So we're going to say, using the formula, 675 times 675 plus 1 divided by 2. So just plugging in the last term for n. In this case, it's going to be 675 times 676 divided by 2, which is going to be 228,150. Alright, So now we can use our hint. Use the formula s equals n squared to find each sum. So if we have our n squared, because we don't have all those values in there, so dot dot dot, we have to figure out how many terms we have in there. That's our n. So n is equal to 101 plus 1 divided by 2. So it's 102 divided by 2, which is going to be 51 terms. So in that first one, number 37, there's 51 terms. And in this case, it said, well, what is s is equal to n squared? Using that formula, we're just going to have 51 squared, which that means 51 times 51, 2,601. Okay. Alright, for the next one, and I'm just going to erase that previous one. Before we can use our s equals n squared formula, we have to figure out how many terms are in there. In this case, it's going to be 999 plus 1, which is going to be 1,000, divided by 2, so it's 500 terms. So n is equal to 500. So this one, s is equal to 500 squared, which is 250,000. So just plug it into a formula there. Alright, use the formula for finding the sum. Okay? So we are going to recall, one of the things you need to recall here, before and in your previous, so you have n plus 1 divided by 2 up there, and that's what we did before. So when we're looking at use the formula to find the sum, we have 1 plus 2 plus 3 plus dot 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 plus n to discover the formula for finding the sum of 2 plus 4 plus 6 plus. Well, we were given that other formula. Now we got to look at it and compare. If this is the formula for the first one, for this, we got to use that information to figure out how we can make a formula for this one. Okay, so if I pair the yellow one up, I need to figure out if that's for the yellow one. So what's happening from here to here? From, let's see, let me get a different color for you. From here to here. What about from here to here? Compare the yellow one to the purple one. What's going on? What about even here? What are we doing to get from yellow to purple? Good. You're multiplying by 2, right? So what we can see is if we take 2 times this original one, formula that was given to us, then we can simplify here. This 2 is going to cancel with that 2, and n times n plus 1 will be the formula for finding this sum. And this is going to be our answer. So in this problem, this one was a little bit different. They gave us a formula for finding the sum, and we used a formula that we recalled using before that we saw on the PowerPoint. And then said, well, how did the first formula relate to the second formula, and how can we imply that to make a new formula for the second set of sequence that they give us? So just a little bit of practice there. All right, number 53, moving on to the next one, it says, use the formulas to find the 16th square number. And then they tell us if s of n is equal to n squared. So we're looking for the 16th one. So that tells me we want to know when n is 16. So put that in the formula here, and you're just going to get 16 squared. So the 16th number for this problem, 16th square number, is going to be 256. Okay, use formulas to find the 9th pentagonal number. So first of all, you need the formula for that. So they'll say, let me put this in blue. Pentagonal number is n 3n minus 1 divided by 2. Alright? They want us to find the 9th. Okay, so you want to make sure you write that formula down because you might need it later if you haven't already from your PowerPoint notes. So then it says find the 9th one. So we want to find when n is 9. Therefore, we're going to plug 9 everywhere there's an n. So you're going to put 9 here and 9 here. So 9 times 3 times 9 minus 1 divided by 2. Order of operations say 3 times 9 is 27. 27 minus 1 is 26. 9 times 26 divided by 2 is equal to 117. So a lot of this lesson is just using the formulas and applying the formulas. Okay, the next thing is, and you want to write these down, an arithmetic sequence in the nth term is given by the formula. So this is a formula you want to write down, and you can use this, you can have this on a formula card for your test. Okay, and this is a formula, you may have it on a formula card for your test as well. In these, your a sub 1 is your first term, and your d is your common difference. Okay. When we have a geometric sequence, a sub 1 is your first term again, that's consistent. But this time, your r is a common ratio. Alright, so we're going to use the formula to find the 11th term. Alright, so first thing we got to do is we got to establish, is it an arithmetic sequence or is it a geometric? Because then we got to know, do I use this formula or do I use this formula? So first task is to figure out 2, 6, 10, 14. Looks like they're adding 4 every time, right? Add 4, add 4, add 4, so that is good, an arithmetic sequence. So I'm going to make a note. Arithmetic. So I need to use my arithmetic formula, so I'm going to write it down. A sub n is equal to a sub 1 plus n minus 1 d. Alright? Make sure you use the correct formula. Next, I'm going to put my first term. Remember, a sub 1 is my first term. What is my first term? 2. Good. And d is the common difference. What is our common difference? 4. So first thing is we're going to plug in some things. So a sub n is equal to 2 is my first term. And what's the last term in the sequence? Or how many terms, what term are we looking for? Right? We're looking for the 11th term. So when n is 11, also d, we said the common difference was 4. So after you determine the formula to use, you plug in all the things that you know, which is the first term, the term we're looking for, and the common difference. And then you just do order of operations here. So you're going to have 2 plus 10 times 4, which you do multiplication first. So you do 10 times 4 is 40 plus 2. So a sub n is going to be 42, and that's what we're looking for. Okay, so remember, here were some of the things we looked at. M was the 11th term. A sub 1 is the first term in the sequence, and your common difference is, in this case, it was positive 4. Okay?